Contineu.Ai, led by Harshil Naik. Contineu.Ai is turning hard hats into smart hats. Using helmet-mounted 360 cameras, they auto-generate 3D as built of construction sites and flag quality defects across trades. Harshil, over to you.
So when we started out this company, right, the idea came from my father's business, who was also into manufacturing and infrastructure. And we started thinking about how should projects be managed from the ground up, from first principles basically. And we realized that the problem wasn't that softwares didn't exist for different verticals. For all verticals, you'll see a lot of softwares already do exist. But the core problem that we found was that manual data entry is the largest bottleneck to any software being used. People have to spend an insane amount of time being on sites and actually feeding a lot of data into these softwares, and then also more time in consolidating all of that data through Excel sheets, through WhatsApp groups, or through other meetings that they have to do. All vertical softwares require manual data entry, and the bigger problem is that incorrect data leads to bad decisions. Why? Because currently the way that the data is collected, there's limited quality coverage. People collect data about progress, people collect data about materials, but quality is not covered. Beyond that, people cannot keep track of 100 different things going on site. There's a lack of cognitive bandwidth. Generally, we also see a resistance to site walks. People don't really want to walk on sites a lot. They end up spending around 2 to 3 hours per day in just site walks. The last issue is something that is very India specific, that there's a general influence and escalation avoidance tendency. People generally tend to solve things amongst themselves rather than escalate it to a software or to management to fix them. And we solve all of this using visual data. That is through the use of 360 cameras mounted on your hard hats. How does that work? You mount the cameras on your helmets, walk around the entire site floor by floor. All of those videos are then uploaded by your team, and then that's it. No other human effort from your team. We process those videos and create 3D as-built models which are aligned to your floor plans or BIM models depending on what you use on your sites. Once those are aligned, we then run our proprietary detection and segmentation models to extract meaningful information from these models. So we've started with quality as our first set of information that we're extracting. How does that look like? This is the map view of the platform, wherein the floor plan is overlaid with the blue path of the engineer walking on that floor that you're seeing. Every point in that path is a point you can click and go to that site virtually. So for example, if I click on any of these points, you'll be taken to a 360 panoramic image of that site. What's more, because we're structuring data in this manner on a building floor and date interface, we can also allow users to add field communications and notes to any location on the image. So your field communications now shift from a WhatsApp chat interface into a visual interface, which is structured by the location on site itself, so that communication can be threaded across locations rather than happening in one WhatsApp group. Beyond that, now comes the quality part. How are we extracting meaningful information from the data that we've collected? So as soon as you click defects below, certain colored dots pop up on the map view. These colored dots are color-coded defects that are automatically detected by the detection models we've trained and are marked on the images as well as on the floor plans. The orange dots here are structural defects because this is a floor on the structural stage. And if you click on any of these defects, you'll be taken to that part of the site with the defects automatically marked out. So you can see here a honeycombing has been marked out by the algorithm. So this is about QC, which is quality control. How do you find defects? Once these defects are found, they are also tracked through an entire aging analysis and NCR flow. You can track how the defects progress over time. You can compare at any location of the site. And the QA part that I was talking about, this handles QC. QA part is about checklists. You can then virtually fill any checklist pre, during, or post inspections on the virtual dashboard itself. So this essentially removes all of your effort from your engineers to keep going on sites, keep collecting data, and bringing it back on WhatsApp groups or Excel sheets. This is the QC flow, the NCR flow that we handle on the platform. You can raise an NCR. It is assigned automatically to all the subcontractors that you pre-fit into your system while onboarding. There are certain levels of notifications that are raised to them until they are fixed. Management escalation is always optional. Once the action is taken, there is an aging analysis loop that keeps happening, again, completely automatically. All your team needs to do is keep taking scans from sites and then keep coming back and uploading them. And then the defect is closed. All of this being blanketed by comprehensive reporting across Excel sheets, PDFs, and CSVs. What defects do we currently support on the platform? We support almost 150 defects across all categories, across all stages of a construction life cycle, right from structural work up until finishing and fit-outs. I'll keep this up for a minute for you to look, but yes, you can reach out to us anytime and we'll be happy to provide you with the list. Lastly, this is us, the team. I have a background in robotics and machine learning from IIT Bombay, did a bunch of research with 3D reconstruction, as did my co-founder from IIT Madras. We've been building this company for about 3 years, and we've seen this problem firsthand. My co-founder has seen this problem at her previous role at a European construction tech startup, and I've seen it with my father and his business. So I'll conclude at that. Thank you so much.
Round of applause for Kanao here. And your 3 minutes for the Q&A from the jury starts now.
All the data you said is being captured by the camera mounted on the helmet, right?
Yes.
You also said there's generally a resistance to site walks. But technically, for this to happen, somebody has to do a site walk, right?
Yes.
It cannot be done by...
Exactly. So the nuance there is the resistance to site walk is for your project team engineers. But this can be done by an unskilled resource.
This can be done by anybody.
Anybody.
And you talked about these defects which are already there, which your algorithm points out. Can we feed our own? Everybody has a different tolerance levels, right?
Yes. So for that, what we have is we have a mobile app on which there is an audio interface that we give you. So whenever you're walking around on sites, you've connected the camera to your mobile app, right? If you see a defect somewhere, you can just look at that defect and speak into the phone. So wherever you're looking, a defect will be auto-parsed by an LLM. An LLM will essentially understand what you're saying, and it will mark it to the location where you're looking at. So then we've essentially removed all friction to collecting data or getting data from your sites with respect to quality.
So right now the use case is only QA, QC, or there are other use cases?
So this is the first module we've built out to validate that this model of data collection works. We want to essentially eventually become an entire project management software where things like your progress updates, quality updates, as well as your material usage all come automatically from these scans rather than somebody having to keep going and collect it.
How do you make money? How do you charge?
So we start at around 4 rupees per square foot per year, but this pricing obviously comes down depending on the volume because we follow standard enterprise pricing as well.
What's the accuracy of these auto detection of the defects?
So,
we look at a 95 to 99% accuracy on most of these defects. And we also have people who are always reviewing all the defects that come through, and we make sure that we do not ever give a wrong defect to the site.
Who will correct them?
So we have a team of people who also review all of our annotations and all of the detections that come through.
So let's say you as a developer give us a list of 10 new defects that you want to add to the platform, right? Within a lead time of about 2 weeks, we're able to train models that can get to around 85-90% accuracy, which is then corrected by these verified civil engineers that we have. But beyond that, for all of these defects, we have accuracy metrics for models that are already trained. So these are all automatic.
Is there anyone else who is doing or building anything like this?
So usually when you end up seeing computer vision in construction, it always stops at things like cracks and honeycombing. But we did not really stop there because we wanted to solve for the entire life cycle or the entire use case of the project. And as far as we know, there's nobody else in the world who's doing this.
Observance does it?
Observance does scan to BIM solutions, and they do thermal scanning, but they do not support any of the defects that we see.
None of them?
None. Barring basic things like cracks and honeycombing. Sure.
Harshil, how does your output integrate with our existing PMC stack?
So we are building integrations to standard PMC software, PM softwares like ACC, Procore, even things like Microsoft Project. But truly where it starts integrating is on the BIM side of things. If you have a design BIM and we start updating that design BIM with 3D locations of all of these defects, then that is true interconnectedness of things, and that is where we see our company going forward. Eventually, we want your sites to run on a BIM-centric project management software rather than being run on an ERP or a database-centric project management software, because it's more easier and it's more intuitive for everyone.
So then, as of now, your target market is pretty limited if someone is on BIM. But
No. So we support non-BIM use cases as well. BIM is something we're developing internally. But yeah, that's the main reason we started with the floor plan interface.
and 4 rupees a square feet, that too in city like Bangalore, we are a pretty cost-sensitive market. How will you talk through developers? There are, I think 70-80% of the developers whose cost of construction is 2,000 bucks. If you talk of 4 rupees for monitoring properly, he'll put in an army of people. So how do you talk through such clients?
The thing is, for example, one of our clients, I'll not name them, but they're from the Delhi NCR region. They have 4 separate independent entities on a site to monitor quality issues, and 4 separate entities marking out defects separately on separate Excel sheets that then the project team is tracking. So they're already spending a lot to just figure out and track quality issues and defects, mainly because of the human element of it. People don't want to escalate things to management because they don't want to be held accountable for things. But this becomes an objective third-party source of truth for your sites. It tells you things about your sites that are not have not gone through any human filter. So that is where they see the value.
I'm just coming back to the cost again. 4 rupees for a 5-year project is 20 rupees. Million square feet is 20 crores. That's a big number, right?
And that comes from the amount of data that we're processing and storing for you as well. The huge amount of visual data that we're processing, it's almost 2 to 3 GBs of videos per floor for every scan that we take. And if you do that thrice a week, that's about 6 GBs to 10 GBs of data per floor. Move that over 5 years, that's a huge amount of data that we're processing regularly for you. So that's where the cost comes from.
But it will become a hindrance.
Sorry?
It will become a hindrance. I agree, because the cost is too high. It will not fly that easily.
Let me explain the breakup of the cost in a certain manner, and that will, I think, clear things up. When you look at our internal pipeline, right, which is going from the video to the 3D model, that is the most expensive step for us. This step is not very expensive. So when we start building more integrations for this, the cost here will be offset there, is our internal plan. But this first step is the most expensive step.
And since we're fundamentally collecting visual data about your site, right? Over time, we'll be building your models, we'll be understanding how your progress is going on, we'll be understanding material, quantity usage, where things are going wrong, and overall improve efficiency throughout your entire site. And apart from that, compared to like humans, machines don't have cognitive bandwidth. Machines don't have issues with processing for a long time. So we will ensure that all the defects on your site are there, and you will also have timely, like you handing over your project on time, catching all snags, catching all defects, and actually giving a very high quality build rather than missing out, because humans don't tend to have as much cognitive bandwidth as a machine does.
But your processing is also limited to the person walking with the camera, right? So where he's looking, where his eyes are going or her eyes are going, it depends on that, how well your data is processed.
So since it's a 360-degree camera, the direction of the head movement, none of that matters. That is one. And secondly, we also have other tools to ensure and look at how people are walking through the site. So if there is a site engineer, or like if there is a project manager who's looking at it, they can always look at how the site engineers are walking around. If areas are missed, we will point it out and we will tell you that this area has not been covered. So
essentially, we give them heat maps of where they've walked and where they've not walked. So if a certain area is not covered, it's automatically flagged.
Thank you, Harshil and Kanao. A round of applause. One question from the audience.
Is this already tuned into your LLMs that you would auto-detect it? Is that what you're providing as a service?
yes, so basically we don't use LLMs for quality detection, but all our models are tuned to detect all of these defects that were pointed out, and it'll automatically do it.
So at the end of it, you take the video and all these things pop up. Is that what you're saying?
Exactly.
And the visual and reporting, is it, do you provide this as a service or do you give it to developers? So what is your model?
No. So we give it to the developers, and then we have an onboarding and training period where we train their teams to use this so that they can use it themselves. But on their end, the effort only is to walk around the sites, take the videos, upload the videos, and that's all.
Okay. In that case, I think cost is a big factor here. You don't have to pay storage costs because that would be with the developers and they're going to pay for the storage. So
if you're deploying on developers' cloud networks, then sure, that's not going to be a cost, and the pricing will get affected that way. But generally, developers don't want to take the additional bandwidth of actually managing their cloud infrastructure separately for something like this.
Okay, so that's a different topic, but good job, guys.
Thank you, sir.
Very impressive.
I think some more questions we can take it post. I mean, probably during lunch, but a round of applause for Harshil and Kanao, guys. Thank you, Harshil. Thank you, Kanao.